Dear students, let us try to understand how to write the practical inorganic chemistry practical salt analysis. The first thing you need to do here is to write down the experiment number. Okay, so in the beginning here you will write down the experiment number. Then on the right hand side you'll put the date on which you have performed the experiment, not the date on which you are writing the practical. Please keep in mind. Okay, then you'll be writing the aim of the experiment. The aim of the experiment will be, you can see it's written here, to identify the acid radical and basic radical present in the given sample. Then you have to write down what is the color of the salt, what is the nature of the salt. By nature we mean whether it is crystalline or amorphous. When you will be doing the practicals, how will you identify whether a salt is crystalline or amorphous? When you touch the salt between your fingers, if you can feel the granules, then it is crystalline. And if the filling is just like talcum powder or turmeric powder, then it is amorphous. Okay, and solubility, most of the salts given to you will be soluble in water. So solubility will be soluble in water. Now this part which is given, that is just for your assumption. This is not to be written in the practical record. Okay, by looking at the color we can guess what could be the possible radicals present in your salt, basic radicals. And looking at the nature, deliquescent, I hope you know the meaning of deliquescence. Deliquescence means if you leave the salt open for some time in the in open air, leave it open in the open air, if the salt absorbs the moisture from the atmosphere and turns to a liquid, then we call it a deliquescent substance. So common deliquescent substances are copper nitrate, ferric chloride, and these are colored, and the colorless ones are zinc nitrate, zinc chloride, magnesium chloride, etc. Alright, now let's go to the writing part. The first experiment which you will be writing is dry test for acid radical. Now under acid radical, you know acid radicals are negative radicals. That means the radicals which carry negative charge. Now we will make 3 columns as it is written here. The experimental part will remain same, that is a small amount of the sample is heated in a dry test tube. Now I will be explaining it with reference to say calcium chloride. Suppose my salt is calcium chloride. Okay, so I'll be telling you all the observations in terms of calcium chloride. So you see your acid radical out here is chloride. So wherever you will find chloride present, they in the write up, those tests you have to write as positive. Rest of the radicals you have to write as negative. How do we do that? You see, the first observation you see, it is for carbonate. So that means here what will happen? You are not expected to see this if you perform the experiment. So how will you write? Here you will write no colorless and odorless gas is evolved to turn lime water milky. And in the inference column you will be writing carbonate may be absent. Then you will write the second observation. No colorless gas evolved with rotten egg smell to turn lead acetate paper black. You can see which turns it's written here, but we are making some changes. When it is absent, we are writing to turn lead acetate paper black. So here what you have to write? Sulfide may be absent. One thing you have to remember, all acid radical test, all dry test, the inferences should be written with maybe. Now you see, I am taking the salt to be calcium chloride. So chloride is supposed to be present. So here what we'll write? A colorless gas with pungent smell is evolved to which forms white fume with ammonia. So here you have to write chloride may be present. Then you continue with the next one. Since nitrate, this test is meant for nitrate and nitrate is not there. So we'll write no reddish brown gas with pungent smell is evolved to turn ferrous sulfate solution black. So nitrite or nitrate may be absent. Similarly, we'll be writing for bromide also. No reddish brown vapors with pungent smell is evolved to turn starch paper orange yellow. so bromide may be absent. Then the last, dark violet vapors evolve to turn starch paper blue, so you have to write iodide may be absent. Okay, you please don't write iodide may not be present and all those, don't change the language. Okay. So that's how you finish with the dry test for acid radical. Then you go to wet test for acid radical. Under this you may notice that there are two types of solution written. The first solution is called water extract. The other solution is called sodium carbonate extract. Okay. Now, as this water extract is made when the salts are soluble. So what we have to write? A little of the salt sample is shaken with water. Then you need not write if the salt dissolves. Okay. You need not write if the salt dissolves because you know that the salt will dissolve because you have checked the solubility in advance. So here you will write the salt dissolves. The aqueous solution is used for wet test for acid radical and is called water extract. You have to write till here only. Please write only till here. Then in any case, if you ever find that the salt is insoluble, then you have to write if the salt is not completely miscible in water, the salt is shaken with water and filtered. The filtered is treated with as water extract. This part I don't think you will require, probably will not give you any salt which is partially soluble. Okay, then with this water extract you have to continue writing the confirmatory test. Remember, this test you need not write for the time being. Preparation of water extract you need not write because this is meant for only if the salt is insoluble. If you can check, it's written here. Then the first test as per chart is confirmation of sulfide. Now please remember, sulfide and sulfate are not same. Your salt may be copper sulfate, then you will not get this test because this is not the test for sulfate, it is the test for sulfide. Some students make mistake here. So what you will write here, again you will make 3 columns. And one more thing, let me remind you, you are allowed to use both sides of the lab record. A portion of aqueous solution, please don't write or sodium carbonate extract because you have not prepared sodium carbonate extract, is taken in a test tube and few drops of sodium nitroprusside solution is added. Now as your salt was not sulfide, as I said, we are taking the example of calcium chloride. So definitely sulfide will not be present. So observation will be no purple or violet coloration is obtained. Here you have to write no. Before every observation which are absent, you have to write no. Okay. Then you have to write the second test also. To a portion of aqueous solution in a TT means test tube, lead acetate solution is added. So here you have to write no black precipitate is obtained, sulfide is absent. Please make sure when you write the wet test, you write the inferences with is absent or is present. That means you are confirmed. Then we take confirmation of halide ion. So what is the experimental column? You have to make 3 columns as usual. A portion of aqueous solution is acidified with dilute HNO3, boiled for some time and cooled, and then silver nitrate solution is added. Okay. So here you see under halides you have 3 possible ions: chloride, bromide and iodide. Accordingly, their test observations are different. Test is same but observations are different. Since your salt contains chloride with reference to calcium chloride, what you will see, a curdy white precipitate soluble in ammonium hydroxide is formed. So here you have to write chloride is present. And here number B you will write no light yellow precipitate partially soluble in ammonium hydroxide is formed. Bromide is absent. No yellow precipitate insoluble in ammonium hydroxide is formed. Iodide is absent. Then you move to the confirmatory test for nitrate. It is called ring test. A small amount of quantity of freshly prepared ferrous sulfate solution is added to a small portion of the extract and then concentrated sulfuric acid is added by the side of the test tube. An observation will be no dark brown ring is formed at the junction of the layer of the acid and the solution. So here you have to write nitrate is absent. Then we move to the confirmation of sulfate. The test for sulfate is called barium chloride test. So to a part of the extract, barium chloride solution is added. So you have to write a heavy white precipitate insoluble in all acids is formed. It should be the observation if sulfate is present. But in the calcium chloride, definitely sulfate is not there. So what you have to write? No heavy white precipitate insoluble in all acids is formed. So you have to write sulfate is absent. And lastly, you have to write conformation of carbonate. The test is called magnesium sulfate salt. But I tell you, this test we perform only if the salt is insoluble in water. Okay. It's a printing error. It should be if insoluble in water, because most of the carbonates are insoluble. So to part of the extract, magnesium sulfate solution is added. So here you have to write no white precipitate is formed. Carbonate is absent. So that's all about the acid radical test. Then you will do the basic radical test. Under basic radical test also you have to write the dry test first. Again you will make 3 columns. The first column will be experiment, then observation, then inference. The first experiment is called heating in a dry test tube. So a small amount of the sample is taken in a dry test tube and heated over a flame. Now this first observation, since you are not performing this experiment, you have to find it out from the teachers, okay, when you perform the salt. Water droplets appear on the upper part of the test tube. If water droplets appear, then what we confirm? Water of crystallization is present. But if water droplets don't appear, then we write water of crystallization is absent. So there are very few salts which do not contain water of crystallization. So when you perform the experiments, please find it out from the teachers whether the water of crystallization part is present or not. Then the next observation, you see, a crackling noise is heard. If a crackling noise is heard, then what are the possible ions? Lead 2 plus, potassium plus, or strontium 2 plus may be present. But in the as our salt was calcium chloride, you see calcium doesn't respond to this test. So what you have to write here? No crackling noise is heard. So Pb2 plus, K plus, Sr2 plus may be absent. Again I reminding you, dry test should be always conferred with maybe except for water of crystallization. Okay. Then the third test, no yellow, not yellow when hot, while white when cold. So here you have to write zinc may be absent. Then the under C part 2, not yellow when hot and cold. So you have to write lead may be absent. Then you have to write no black residue, copper or nickel may be absent. No brown residue, ferrous or ferric may be absent. And no white sublimate, ammonium may be absent. So when you write, please make sure that these observations go with the inference, okay, side by side. Don't write one here and one here like that. In the chart, of course, it is not written so nicely, but I have marked in the chart, you can check. So that's all about the first experiment under dry test for basic radicals. Then you see the next test is called flame test. And you may see the calcium appears here. That means you are supposed to see some colors when you perform the flame test. So what's the test? A small amount of the sample is mixed with concentrated HCl to make a paste. Small amount of the paste is placed on platinum wire loop and introduced into the flame. The colors imparted to the flame are noted. As I told you earlier, we will not be allowing you to perform the test, but we will be trying to show you the test. So, in the observation column, what you have to write? Brick red color, calcium may be present. And for the rest, you have to write no crimson red color, strontium may be absent. No apple green, barium may be absent. No pink violet, potassium may be absent. No greenish, bluish green, copper may be absent. No dull bluish white, lead may be absent. So that's all about the flame test. Next we move to a very important part of the practical write-up, wet test for basic radical. Here a small portion is missing in the chart. That part you please include. Okay. Here you have to write, before you begin the table, here you have to write preparation of original solution. preparation of original solution. In short, we write OS. Okay. The preparation of original solution should be written how? A small amount of the salt is dissolved in water and is known as original solution. Okay, only that much will do. And when you write this, the format of the table should not be changed. It should be exactly following the same format as it is written here. Don't make 3 columns. Okay. So first column you will be writing to the solution dilute HCl is added. Then you make a small column here and you write no white precipitate, group 1 is absent. Here you need not write Pb2 plus. The groups which are absent, for them you need not write the ions. Then you write, again you draw a line, then you write H2S is passed through the filtrate. Then you write filtrate or solution also you may write. Then here you have to write group 2 is absent. No precipitate, group 2 is absent. Then you write H2S is boiled off, 3-4 drops of concentrated nitric acid is added, boiled, and solid ammonium chloride is added. Here you may include till saturated. Then boiled again and cooled and ammonium hydroxide solution is added until it becomes basic. And here you have to write no precipitate, group 3 is absent. Then again you write H2S is passed through the filtrate, no precipitate, group 4 is absent. Then as you can see, calcium should appear in which group? In group 5. So what we will write? Here also you have to make a correction. It's written HS. Please make it H2S. Please make the correction in your chart. H2S is boiled off. Ammonium chloride and ammonium hydroxide is added, followed by ammonium carbonate solution and allowed to stand. So here you have to write white precipitate of group 5 is present. Now since group 5 is present, you have to mention all the radicals. Ba2 plus, Sr2 plus, Ca2 plus are present. Then to the filtrate, ammonium chloride, ammonium hydroxide, ammonium hydrogen phosphate is added. And then you have to write here no white precipitate, group 6 is absent. So this table is called group separation table. Now since you got a precipitate in group 5, what is your next step? Your next step is to look for the page where you have written analysis of group 5. So here you see it is analysis of group 1, then analysis of group 2, then we move to analysis of group 3, then analysis of group 4. So here you have analysis of group 4. Okay. Oh sorry, our salt is not group 4 also. Our salt is group 5. So here you have the analysis of group 5. So straight away go to this page. Then you write the white precipitate is dissolved in minimum amount of dilute acetic acid and is divided into 3 parts. Why 3 parts? Because in group 5 3 radicals are possible. So to the first part what we do? This is the test for calcium. To one part of the above solution, 1 ml of ammonium oxalate solution is added. Since calcium is present here, you have to write white precipitate is observed. Actually, the sentence should be better to be reframed. You can write white precipitate of calcium oxalate is formed. So calcium is confirmed. To the second part. To the second part of the solution, potassium chromate solution is added. So as you know, barium is not there. What should be your observation here? No yellow precipitate is of barium chromate is formed. Barium is absent. Then you have to write the test for strontium as well. To the third part, 1 ml of ammonium sulfate solution is added. The solution is then warmed. No white precipitate of strontium sulfate is formed. Strontium is absent. So after that, your analysis part of group 5 is over. Then you straightway move to the conclusion. Okay. This analysis of ammonium potassium you need not write because you got group 5 precipitate. If you don't find any of the groups, then you come here. Then you have to write after the systematic analysis, the given sample is found to contain dash and dash as the basic and acid radicals respectively. So here you will write Ca2 plus and Cl minus as the basic, and don't write acidic radical, just make it acid radical respectively. Hence the salt is calcium chloride, CaCl2. Symbol and formula is very important. Okay, so hopefully you understood how to write the practical, and any salt given to you, you have to modify it accordingly. Thank you.